Hello, everyone, and welcome to the Ask the Expert webinar. I have results from PROC PSMATCH. Now what? My name is Tiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenters. First is Kat Briggs, a customer advisor and data scientist here at SAS. Kat is a solutions engineer specifically at SAS, where she applies academic and industry experience to solving problems in life science. She is passionate about creating solutions for real-world data analytics, positively impacting patient outcomes, and promoting ethical analytic practices. She holds a Master of Science in Biostatistics from Washington University in St. Louis. Also on the call is Shireen Eid. Shireen has over 20 years of experience in real-world evidence, epidemiology, and biostatistics. Her passion for better public health has led her to work for CDC and other donors in global health development, focusing on reproductive health and family planning and infectious diseases. Her current focus is supporting regulatory, safety, late phase, and post-marketing activities across therapeutic areas, including clinical and real-world data to glean real-world insight. Why don't we turn things over to our presenter so we can get started? Kat, please take it away.
Great, thank you. Thank you so much, everyone, for joining me. So what we're going to talk about today, we are going to talk about the use case. We are going to talk about what we are going to be showing today. I'm going to give you an overview of custom steps and visual analytics, and we're going to see that in action a little bit. And then we're going to talk about real-time model decisioning, why that's important, who is able to use it, and ways to get started in that. And then we're going to talk about our causal inference methods towards the end, because that's the point of propensity score matching, right? So let's talk about the use case. What are we actually looking at now? So we are specifically looking at propensity score matching. And as most of you already know, propensity score matching mimics randomization when that isn't possible. Whether you're looking at past data, where you're looking at observational data, longitudinal data, when you just have it and there's no way to influence what treatment or what therapies people are getting. It may not be possible because it's unethical. I give this example of knee surgery. It's unethical to open up somebody's knee, tell them you did knee surgery, and not actually do it, right? So there's times where it's just not possible to do that randomized control trial. It could be costly. There's a lot of situations where propensity score matching applies. So what we do is we condition on the propensity score. I also like to call that the likelihood score, the propensity, what is the likelihood of a student or of a subject receiving treatment. So once you condition on the propensity score, each subject has the same chance of receiving treatment. So if we look, for example, at knee pain, my family has a history of bad knees, and so that's what I think about. If we look at knee pain, people who receive surgery for knee pain are going to be different. People in that category, they typically are of different ages. Age determines whether or not you have knee surgery, what your insurance status is, what your weight is, what your previous history with knee pain is. Is it low-grade, long-term chronic? Is it very severe, very fast, right? And so the groups of knee surgery versus not knee surgery, they're different, right? And so we want to make sure that we run propensity score matching. So when we look at knee pain and knee surgery, we have similar groups in the both treatment, knee surgery, and non-treatment, not knee surgery. So we use this to analyze observational data because we want to obtain those unbiased causal treatment effect estimates. That's what we do. We want to see if treatment has a direct influence on our outcome. So we determine what the likelihood of somebody receiving treatment is, so then we can match and put into equal groups, so then we can directly see the treatment or the effect of treatment on the outcome. So the use case and the data that we are looking at specifically, and everything that you will see later in this presentation, we are using data on a simulated, it's a simulated data set based on an observational fibromyalgia study. So this is simulated, so do not take any medical advice or make any sort of medical choices based on what you see in this presentation. It's simulated. And the goal here is to estimate the causal treatment effect of opioid versus non-opioid medication on final pain scores. Now, we know fibromyalgia causes a lot of chronic pain, and we want to help subjects who have that pain. But we also know that opioid use comes with a lot of side effects that are not necessarily worth the pain reduction, right? So we want to see whether non-opioid medication does as good a job as reducing pain as opioids. Because then we can choose the non-opioid pain medication without any detrimental effects or any lesser pain reduction effects on our final, on our subjects. And to me, that's great. And so I used the data and a lot of the code that I used and modified and will show you is from this book that I have on the left-hand side. It's real-world data, real-world healthcare data analysis written by Doug Ferries and others. It's specifically looking at SAS code and running through the examples using PROC PSMATCH and other SAS procedures and data steps, but it provides a wealth of information. Even if you are using open source methods, it goes through very deeply and technically on all of the things we're going to talk about today. So if you are looking for more information, I highly, highly recommend this book. It provides a lot more in-depth look at propensity score matching and then the causal methods. So let's talk about custom steps and visual analytics. These are the two tools that we are going to be using later on today, using for our real-time decisioning, using for our causal effect analysis. So a custom step enables you to create a user interface for users to complete a specific task. So this is a no-code way for people to access analytics and results. So it is something I do not have any back-end coding experience, but I am able to create almost like an app that anyone can go in and select what they need to get the results they want. So it's great. So you can easily share macros once this custom step is written to allow a user to use it and run it without modifying any underlying code. They can see it, but they can't touch it, right? So once you create a custom step, you can use it in flows. We're not going to talk about today, but you can use it in Visual Analytics or standalone. So you use it once or you make it once and you can use it in a lot of places. So you can use a no-code designer, which is what I use, or if you're proficient with JSON code, that's what the interface is written in. So if you're proficient in that, please go ahead and use it. And then you can save custom steps on a local network in Git or any other shared mounting system. SAS actually has a GitHub with published custom steps that my SAS teammates have published. So there are many things in there that you can look and download and immediately start looking at. And then the next tool that we're going to be using is we are going to be using, we call it visual analytics. So we explore and visualize data. So this is a point and click visualization tool within SAS Viya where you can build interactive reports and dashboards to gain deeper insights quickly. So I use this platform with a custom step to create a real-time modeling dashboard for anybody to use. We're going to take a look at it. It's really slick. I'm very excited. And so those are the two things that we are going to be looking at today and using for propensity score matching and real-time decisioning. So I am going to jump and I'm going to share my screen and we're going to look at these two for the first time. All right, and I'm going to make this just a little bit bigger for us all to see. Oops, that's a little too big. So what you are looking at now, if you are familiar with SAS or SAS Studio, this looks very familiar. What I have here is a PROC PSMATCH. Now, most of you have already seen this before. It is a very basic procedure if you know, if you've used it before. And then I have this causal inference. And we're going to skip that for now, but it's just a t-test. And I'm going to run my PROC PSMATCH. And I get all of my results over on the right. This should look very familiar. We have all of the information, the standardized difference, the mean difference, those will come up. And we have this plot. This plot tells us when I run this propensity score matching, how well the matching does to make those two groups, opioid use versus non-opioid use, the same, right? We are looking for a reduction in the differences between these two groups. So if we look at, for example, if we look at physical symptoms at the beginning, the difference between the opioid use and the non-opioid use were pretty different in how people recorded their physical symptoms of fibromyalgia. But after matching, that difference has reduced to nearly zero. We might say zero. We can't tell specifically from this plot, but essentially zero. And that's what we're looking for. We're making sure that not one of these influencing factors will influence our causal test, right? We want to make them as similar as possible. And all of this should look very similar. We can look at distributions of age. The two groups were pretty similar on age to begin with, right? But when we look at this, it seems like the matching didn't do much because they were already pretty similar. The distribution in the non-opioid was a little bit wider, but I would say overall they look very similar. And so that one, right, matching didn't change it that much because there was actually not all that much to change to begin with. And so this looks very similar. So I don't know about you, but when I run PSMatch and I am looking and I am, testing and exploring, I like to be able to test multiple things, right? And so I like to, what we call it SAS, I like to create macro variables. So I'm going to say let methods, I'm going to call it match method equal optimal. Oops. So when I run this code, I can put in match method in here. And so when I run it, it should look the same because I used optimal. And now when I run this, I am able to, you know what? I don't think optimal is the right call here. We can talk about which one to choose later. But I am actually going to try greedy, right? So if this usually, PROC PSMatch usually exists in a longer line of code, but you can see I'm able to run it. I don't have to go into the code. I can start at the top. And I want to change a little bit more, right? I want to say, I can say, let caliper, the caliper width, we can talk about what that means later, but I don't have to change it. We'll just say match, just so we know it's a macro variable. Right, and so now I'm able to modify, and instead of going into that code, I can modify at the top and run it. For those of you who are code a lot, This is not new, right? But what's really great is when you create this list, it looks like that caliper width was not appropriate. We missed some of those treated, so we'll have to go back and look at that. But what's great about this method is when you pull those out, right? That means that I don't have to touch or I don't have to look at this code. I pull out everything that I want to test and modify. I pull it out, right? So these stay there. It's the opposite of hard coding, right? If I were to put optimal in here, optimal is hard coded, but I want to pull it out because I want to modify that. And so what custom steps do, custom steps take these macro variables and they create a UI on top. And so how that looks, let's just create a new one. I'm going to create a new custom step. And I have, excuse me, thanks for all the dealing with the clicking. I have this PROC PSMATCH, so I'm going to copy this code because I know it works. I'm going to put it in the program. And what are the two things we had, right? We had this match method and we had this match caliper. So what is that? So one is a word, one is text, a word, right? The way that the procedure is designed, and caliper is a number. And so what I'm going to do, I'm going to drag and drop so easily text and numeric. The idea is match method. And this is going to be what? Match method to use, right? And then the next one is going to be a number. Where did numeric stepper? Nope, 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 nope. Oh, text or numeric field. It's the same one. And this is going to be a match caliper. Is the caliper width. And here, we are not text, we are numeric. And we are allowed to say the default value, let's do 0.25 because that's the standard. Minimum is 0 and maximum is 1. So we're going to exclude those in the range. And so what we have here is I am able to now, what match method to use? I want to do optimal, and what caliper width, that didn't work last time. So I'm going to do, I'm going to make it a little wider. Let's do 40. I'm going to do a little bit wider, and so I am able to run this. Actually, I am able to run this. I got to save it. You can see all of those. I am going to be able to run this as a standalone macro. So let's go and find that. You can see I have a lot of other things. What did I call it? I just called it custom step. And I am able to run this optimal. And then caliper, we need to make it a little bit wider, 40. And I'm able to run this. I didn't have to change the code. Oh. We got an error. Could not, oh, sorry. Like I say, if you get an error, you know that it's real. So I can run this once I create the connection. And we'll open it up again. Optimal, and we know that we got to make that a little bit wider. Oh, shoot. All right, so anyway, so this gives you keyword assign. Oh, shoot. So you're able to run it. I'm so sorry this, isn't I assign all, oops. We'll save it one more time and we'll give it a go because I am nothing if not tenacious. No, it should be all assigned. We'll come back to this. We'll come back to this at the top, but I want to move on. I want to make sure we get everything that we need to. But what it is, what it shows you, you are able to create this app, open in a tab, create this app that somebody would be able to input what they needed and get out all of the results and log and code, right? As you can see, the log pops out. So nothing is behind the scenes. It's all very upfront for you. You're able to create that app. So I'm going to stop sharing and jump back to what we need. So let's talk about the causal inference and the model features that we need. We saw a little bit there. We talked about the matching method. We talked about the matching constraints and the algorithm. So when we run propensity score matching, we need to consider three broad categories of features, right? So the first is the distance metric. And this considers, you need to consider what the best metric is to reflect the closeness of matched subjects, right? So the closeness is how close do we want them to be? So this is where you can use, if you use exact, right? So do you want to measure exactly, right? The genders have to be the same. If you match two subjects, female, they both have to be female, for example. You can use the propensity score, right? That is a number. That's the likelihood, the propensity of being prescribed the treatment, and that's the number that you can use to match. You can use, we call it the linear propensity score. This is just the logit of the propensity score, and it just gives a more linear measure of that closeness. There's another one, the Mahalanobis score, and this is really great for normally distributed variables, but we know in real world evidence that's not always the case. So number one, you have to decide what is your distance metric. We can do exact, the propensity score, the linear propensity score, or the Mahalanobis score. The next thing that you have to look at is you have to look at the matching constraints, right? So are we using a caliper width? And that caliper means what is the max distance that we allow, right? If your caliper width is 0.05 or 0.1, that's going to be very narrow, and the variables have to be very, very close, right? If you want to open it up, and do a wider, like 0.4, you're able to capture more matches, right? You're able to put people together that have a little bit of a distance in their covariates. But then again, you're opening yourself up to not having equal groups, right? So that is another thing you got to think about and balance. What are we answering? What does our data look like? Do we have the ability to be a little more loose in what we offer, or do we want to keep it very tight and very constrained, right? We can also look at whether or not we're matching with or without replacement. So if we are putting somebody in there and making a match, can we put them back in the pool, or are they out of the pool forever? Are we doing ratio, right? Ratio means whether or not we have treatment, one control, or one treatment, two control, one treatment, three control, right? And so those are our matching constraints that are all determined by what is our question, what does our data look like, and what are we trying to answer? And then we have the matching algorithm, right? So the matching algorithms look specifically at whether or not we are doing greedy, whether we gobble people up as fast as we can, whoever is the closest. Are we looking at optimal? Do we want to make sure that our data overall and matching overall is optimally minimized, right? So those are the three: looking at the distance metric, looking at the matching constraints, and looking at the algorithms. And the next thing that we have to consider are reviewing the results. So after we determine how are we going to match, how are we going to review the results? So we need to look at the distribution of covariates. So all of those inputs in our model, we're going to use box and bar charts to compare the pre-matched and the post-match distributions. We are going to assess standardized mean differences. So we peeked a little bit at our data first to see in those results. We want to get as close to zero as possible, but we know that's not always the case, right? Typically, when we look at results, less than 0.1 is acceptable. But again, it depends on your data. It depends on the question that you're asking. It is a mix between an art and a science. We have to balance all of these factors to get the right results. And then at the end, we need to estimate the causal treatment effect. And so we use those match observations to determine the causal effect of the treatment on the outcome. And so we are going to jump again to our dashboard. And what I am going to show you here is a dashboard of running that custom step that I created that we have to go back to create, creating that custom step and using it in our dashboard. Now, all of these things are possible variables for propensity score matching, right? We have our input data set. We have what our outcome variable is, our treatment variable, our numerical matching variables, our treatment group, our class matching variables, and our reference group, right? All of these things, when I think about running propensity score matching, of course, we have our analysis plan, but when we're exploring, some of these things we might want to test, right? So if I have these 10 numerical matching variables, and my epidemiologist comes to me and says, Kat, why didn't you add treatment duration and symptom duration, right? We know that people who have symptoms longer get treated differently than people who have just started having symptoms. We need to add those to our analysis. And so what we're able to do, we are immediately able to put in our symptom duration. I'm not looking at the code. I don't have to remember how symptom duration is spelled. I can add it quickly here. And I actually missed this variable last time, so we're going to add that beginning metric too. I am able to look and see all of the variables. And immediately, right away, I am able to modify my analysis to include those two. Now, that's not all, right? We have those, what the propensity, what those initial variable model variables are, but I also can change and test those different matching methods and features, right? I originally choose this logit of the propensity score, but I'm going to change. I'm not going to do the linear. I'm going to do the straight propensity score. I'm not going to exact match on gender because we know that gender doesn't necessarily, well, maybe gender doesn't necessarily influence the outcome. So we don't have to exact match on it. But if we want to, if I'm like, oh, wait, just kidding. We need to match on gender. That's very important for here. I can add it back, no problem. Here, I have that wide caliper width because we ran into issues before. I'm going to do match weighting, and I am going to do greedy, and I'm just going to do 1. We're just going to do 1 to 1 and have it work. So what have I done? I have taken the basic propensity score PSMATCH code, and I have visually, no code, modified what we are going to run. And so I have done that without taking anybody's code. I have done that without editing anything. I've done that without, deleting something I wasn't supposed to delete. And now I am able to run this code. So last time this has no race, but what we did, we'll do greedy, and we'll do, what did I do? I did greedy, and I did exact match on gender. And so I can name it greedy gender. And so I am able to run that code, what we saw in SAS Studio, what we should have seen in a custom step that I wasn't able to get working for you today, but we are able to run that code from a dashboard. This is so great for those on your team who do not have the specific skills, oh, and we're done, the specific skills to go in and change code. If we don't want, somebody to see all the background code work, this is perfect. And so now I'm able to see, right? I have my greedy gender, great. I can go in and look. Nothing is behind the scenes. Nothing is left in this black box nebulous. I can see exactly what I ran. So we are not having people, run code and then just like lose it and say, how did you get these results? These results are here for you to look at. And what's even better is that the job log is also saved. Oh, it looks like I have a warning, right? If there's a warning, if there's an error, I can see it. And this job log is saved for everybody to go back and look. So this seems very, anybody can access it and they can, go crazy with the analysis and like, do we trust people? And yes, they can, but there is a backup and this is saved. So no matter what people run, we have access. It is fully transparent, right? So the job results and log are available for everybody. What I have here, we also can look at the treatment effects. We're going to look at that later if I can hurry it on up and stop chatting so much. And so what we have here is we have our real-time modeling decisioning. And you can see in this that I have all of these that I have run before. We exact match on gender. We have greedy with an exact match. We ran one with looking at no race. We did an optimal. We have all of these models that I was able to run, and I can directly compare them without running back and forth. So I did a matching with replace, and I can look and I can see, and to be honest, this doesn't look like it did a great job matching. I can directly compare that to the greedy gender that you just saw me run, right? What was that, 2 minutes ago? And I can see that it did a better job at correcting for some, but not necessarily for others, right? Is this worth it? We are under the threshold, but do we need to, maybe look a little bit further? I am able to directly compare immediately after running which propensity score model is going to be best for my question and for my data, right? I can run as many as I need, and it's going to adjust as we see fit, right? We see the standardized differences, right? We can check. I can hover over this variable. Technically, it's under what is suggested, but it's very close. Is this what we want for our data? We can look to see at our treated and control, right? Are we okay having, equal amounts? Do we want to bump up our overall subjects and we want a little bit more to have a more robust causal treatment? I can look at the distributions of all of our input variables. How does age change? How does the physical symptoms change, right? Have we matched? Does this match? We added physical symptoms specifically here. Does this look like it's doing well, right, when we match it, right? So I am able to take everything that anybody has run or who I choose to run and look at it specifically. This really empowers everyone on the team to have access to the analysis, the the whole process, right? We are sharing, we are democratizing what we have for everybody to use. And it is incredibly powerful to allow somebody who may not have the skills or the background to run the code, to have access to this tool, to be able to make those decisions. Which one of these models, I do not recommend running 10, right? You should filter it down before, but this is just an example. Able to choose in real time which one is the best. So I'm going to stop sharing. I know we promised to get to causal inference, the methods, and I'm going to talk about them now. So some methods, there are of course many others. Any method that you use to test the difference between two groups, you can use here, right? If we are testing the difference in any two groups, you can use it here. But the standard ones are t-test, and then a linear regression. You can, if a fixed effect or a weighted is more appropriate, or you can use a complex bootstrap. So if it's only really used with a variable k to 1 matching, and only when matching without replacement. So if you match with replacement, it gets a little dicey. It is possible, but it's not as easy for your developers and coders to code that. So we save that one specifically for variable matching and only without replacement. So I promised you I'm going to jump back to the screen and share it very quickly. I see that you have questions coming in, and I want to make sure we get to those. And so we have our screen here. Now you can see we don't have a tab here. Sometimes, right, we don't want our causal inference test to influence our choices, right? We want to make the right choice for the right data and then check the causal treatment, right? So it is hidden here from anybody who uses this tool. But that doesn't mean that it is not saved, right? So you are able to, if we have yes here, return treatment effect results as yes, right? It was no for that last one. So we won't see that exact gender here, but we are then able to look at which model did we choose, right? Let's choose optimal. That's the default. That does a pretty good job. We're going to look at optimal. So when we run that PS match, is there a difference between the opioid and non-opioid drugs on final pain score? And when we use an optimal PS matching, the answer is no, right? There is no difference using propensity score matching with the features that we chose, optimal, and whatever else was in that model on pain scores. And this, as a fake example, is very good news, right? Because then we can better choose whether or not we are going to prescribe opioids. And I think that is great, just to reduce opioid use when it is not required. So this is another dashboard that we can look. It has everything we need to see, right? We have the KDE plot with the distribution. We have our QQ plots to make sure this t-test is appropriate for the data, right? Just because we do propensity score matching doesn't mean that a t-test is appropriate, right? But we can see that this looks pretty good, meets all the assumptions that we expect it to meet, and it is not, no difference between the pain scores. And so that is a hidden tab here, right? Because like I said, we don't want our matching choices to affect, or we don't want the effect treatment test to affect how we match. So it's hidden until we want to look at it on the background. So we are almost ready for questions. And I know I rushed through that last part very quickly, but I want to make sure we get to questions. So when we think about propensity score matching in practice, right, assessing and comparing the propensity score matches in real time increases our time to results, increases our time to affecting patient outcomes, which is what we all want, right? We want to positively affect patient outcomes. So if we can choose the best method, right, without going back and forth and sorting through a ton of PDFs, right? We have one dashboard to display everything. We can make that choice in real time because we have access to modify if we need, right? And so if we have that no code analyses, right, it empowers the entire team to make those decisions, right? Democratizes the analytics, allows everybody to contribute to the final analysis and results, right? And again, it automatically, this dashboard and the way that I've set it up, keeps record of all analyses run for transparency. We have to know who ran it, what did they input, what were the results, so we can keep track, right? We want to know who ran what and when, right? So we know our final method is appropriate and was run appropriately. And then, right, we can use the best model features for the data in question, right? It is a balance. It's an art and a science to be able to take your data and your question, right, and apply the right model, including the right features, the right modeling variables to get our final results, right? So it's about using robust, standardized, and transparent analytic practices, right? The underlying code does not change, right, when we run this. So everybody runs the same method when we use this dashboarding, right? But all of the inputs can be modified for what is best for that data and that question. All right, and so now we are on to the Q&A portion. I'm going to let Shireen, if there is a good question to get to, I'm going to hand it over to you.
Sure. Yes, we will be moving into the Q&A segment of the webinar. Just a quick reminder on how it works. If you would like to ask a question, simply type it into the Q&A widget located at the bottom of your screen. We would also love your feedback on our webinar today, so please take a moment to fill out a quick survey by clicking on the survey widget, which is also at the bottom of your screen. Should be popping up for you now there. It's only 4 questions and should only take a minute to complete. Your feedback is super valuable to us, and we will use it to shape future webinars. All right, now onto our first question here. Someone's asking, does the match differ whether or not we use an exact feature?
Absolutely, yes, it does. If we are using an exact feature, right, you are forcing that variable to be same for that pair or that ratio. And so you are excluding some subjects from being part of that group if you exact match, right? It's a little more strict, or it is more strict to have that exact match. And absolutely, it might not change your conclusions, right? Your conclusions might be the same, but the groups that you move forward with for that causal effect treatment are absolutely going to be different if you choose to do exact matching. But sometimes that's great, right? If you are working with hundreds of thousands of subjects, you want to exact match as much as you can because you have enough subjects to match with. In this group, we only had 1,000, right? And so exact matching really, narrows the number of subjects that could be a part of the final causal treatment test because we only had 1,000. So exact matching absolutely will, because it changes who is allowed to be a match and who is not allowed to be a match.
Thank you. Someone else is asking, in your PSM code, you had a weight. Is that something that is part of the data set or a standard part of PSMATCH?
So the weight comes from PSMATCH. So what you can do when you run a propensity, that propensity score model, you can choose what the weighting is going to be, and that automatically comes out. The options that PROC PSMATCH provides is no weighting, right? You can do match weighting, and you can do, I always do match weighting. Inverse, I have it available. Let's just take a look. The inverse, where do I have that? Yes, there are four options, excuse me, for that, and that comes from the match, the model that you use to create the propensity score. So yeah, it comes out of PSMatch. It's not part of my original data set, is the short answer to that. Oh yeah, so the weighting by odds and the inverse probability of treatment weighting. Yep.
All right, thank you. Another question here for you. Is the magic that you displayed, the no-code analysis and results display, is that a function of SAS Via or SAS Studio, or is it a combination of the two?
Yes, so it is a combination of the two. So I created that custom step kind of behind the scenes, and I used custom step, right, to create that visual interface. And then I applied it in the visual analytics module, right? So I created it in SAS Studio and I applied it in the dashboard. So it is a combination of both of those things. And you can create it in SAS Studio and just use it in SAS Studio. Again, I apologize, it did not work as intended this time, but you can use it just there. I like the visual interface because you get all of those extra pieces, those real-time results, right, and being able to flip back and forth. But it's a combination of both of them.
Gotcha. Thank you. We have someone asking, can PSMatch allow for a pre and post-match graph to show a density plot?
Yeah, absolutely. So the dashboard that I created here, those were things that I chose. You can absolutely create plots that show those density plots. I'll have to look to see if it is automatic from PROC PSMatch, and if the plots are pre-created, but creating those plots in Visual Analytics is very simple to create on your own if they're not provided strictly from PSMatch.
Thank you. Someone's asking, I want to highlight the matching method for each model shown on the results page. Can I do that?
Absolutely. So when you are creating your dashboard, you can add whatever you want, right? Because it's an input, right? We chose optimal, greedy, whatever it is. We chose that value is saved, right? It's saved in that model run. So you can absolutely pull it out. Like I have the big treatment observations, control observations, right? You can absolutely pull out. So the person knows you don't have to have it in the model selection. You can pull out whatever you want because it is saved in there and saved in the model and in the run for you.
Thank you. Another question here, can I use this method for other real-world evidence analytics?
Oh, great question. Absolutely. So this is a great method to use for when you have a analytic procedure or practice where you're exploring, where you like to test a lot of different things, right? This is not for, the final total, like, this is what we are publishing, right? This is an exploratory analysis to make that choice of which is the best one. So anytime you reiterate, every time, if your analytic method, requires you to test a lot of different things, or it, requires you to make small changes many times. If you iterate, if you do something, 3 or 4 times in the course of your analytic journey, this is excellent, right? I created PSMatch because that's what my background was in, but you can absolutely do this for any analytic method that you want.
Thank you. Someone's asking, what types of analytics make a good candidate for implementing this solution?
Yeah, I just talked about it a little bit in that last question.
Oh,
But
sorry about
again,
that.
anytime, no, that's okay. Anytime that you have to reiterate, or when you have input from somebody, or somebody wants to know what the results are, right? Without having that background or that skill in coding. So this dashboard and what I showed you is an excellent way to bring in other voices and other subject matter experts, right? Anybody can have access to this and anybody can run those analytics. So if you need more voices and more expertise around the results, this is a perfect method for you, right? They have access. They don't have to say, hey, Kat, can you try this again and don't put age in there? I don't know why you would, but I don't want age in there. And so then I have to receive it. I have to read it. I have to run it. I have to save results. I have to email the results. They have to look at the results. They have to email me back, right? What is that? 7 steps? This is able to do them in 1 step, right? They can come to the dashboard, see what I have already done and say, hey, you know what? I love everything about model number 3. I'm going to keep model number 3 and just subtract age. So anytime you need, you're reiterating a lot, you have a lot of voices in the room that need to see the results and have thoughts and suggestions on how to improve the model or change the model to best answer your question. So that's how I would, determine whether or not to move forward with this process of analytics.
Perfect.
Add something to that, Kat. Anytime we have big data in general on our environments, we want to be very cognizant of the resources that would take for the methods that we're using. Some methods are ideally, just so amazing, and yet they're going to last and consume a lot of cloud resources or bog down the grid or your tenant or server that you're working on. And that's just a function and artifact of feasibility and practicality, right? And I'm sure that your IT department is going to be crazy about a super compute cost because of the resources that are consumed. So if you're thinking about then how you want to show this or how you want to plot it, sometimes the box plots, for example, are good enough for the decisions that you need to make with the methods that you're going to choose. And then sometimes, you want to find the more efficient way to plot your data so that you can make a quick decision. So I apologize for the background noise, but that's just some things that I would consider as well. Just from a scientific perspective and a mathematical perspective, yes, there are some ideals, but when we get to practically implementing it and applying it, sometimes we have some resource constraints that need to be considered.
Yeah, thank you.
Thank you. I'm afraid that's all the time we have for questions today, but if we did not get to yours, we will answer all unanswered questions in our follow-up communities post. Thank you, Kat and Shireen, for all of your answers, and thanks to all of you for joining us. There's a list of helpful user resources and links here on our final slide. On behalf of myself, Kat and Shireen, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.